I believe as a prerequisite to this course, most of you has done some courses on probability statistics in your undergraduate curriculum. ঠিক আছে? Either in engineering mathematics or in some honors subjects. For example, I don't know whether you are a new batch of EC or not. In this current batch, there is an honors paper of BTech, like probability statistics theory. So I don't know whether in your turn it was there, but anyhow, some knowledge of probability theory and statistics you have in your undergraduate curriculum. Okay, so that much background I will take care of. So the concepts of probability theory as well as the random variables. Okay, the random variable means the univariate random variable and bivariate random variables. So that will also be assumed in our lectures because that is an undergraduate engineering maths that has been generally covered. But if any one of you do not have that background or you had not underwent such courses, I request to please go through some basic statistics book, and you can now, libraries are available, library facility. So if you have the library card, then you can make use of it. Okay, also some PDFs and books are also available in net, which deals with the engineering mathematics of engineering statistics. Okay, now here we start with probability theory, and first of all, you know that statistics has actually two parts. There are two distinct divisions of statistics. One division of statistics is called as the descriptive statistics. Okay, and another part of statistics is called the inferential statistics. Okay, so there are two classes of statistics. Okay, join potential. Okay, so there are two classes of statistics. One is called the descriptive statistics, and another portion is called the inferential statistics. Now, the descriptive statistics portions, where we have a set of data and the corresponding frequency distributions are there. That means data and the number of occurrence of that data, that's the frequency distributions of data, and then we define and formulate certain important parameters which actually describe that set of data. Okay, so what are the important parameters or features that describe the set of data? They are very common to you. First of all, it is the measures of central tendency. Okay, there are certain measures of central tendencies which identify that how the data are being clustered around certain points, or what are the general pattern that are being followed by this data. So these measures of central tendency, you are aware, the very common measures of central tendencies are mean, and mean may be arithmetic mean, may be geometric mean, harmonic mean. The other measure is of central tendency median and mode. So mean, median and mode, these are very fundamental measures of central tendencies. Another measure is the sometimes alternatively we call as the standard deviation. Okay. Then how the data pattern, the frequency diagram, which we call as the ogive or the cumulative frequency polygon, how the frequency polygon is picked around a central value, or how much flattened it is. That types of curvature of the frequency polygon is given by the two parameters which you call as the skewness of the distribution and kurtosis of the distributions. Okay, so these things are some elementary concepts of statistics which I assume that these have been, you are familiar with undergraduate curriculum, or even if you have some in higher secondary, if you have some students, they have statistics at your +2 level, then those things are also discussed in detail. Okay, so that quantities and how each data are correlated among itself. So correlation, regression, these are basic concepts, very fundamental concepts, and those things belong to the part of statistics known as descriptive statistics. Okay. On the other hand, the second part of statistics, which we call as the inferential statistics. So in inferential statistics, the fundamental concepts of inferential statistics is based upon the theory of probability. So the theory of probability forms the basis for statistical inference. The theory of probability forms the basis for statistical inference. So probability is used to evaluate the reliability of inference made about a population or of a sample. Now, you know that any event, the happening of any event is actually involved with the chance mechanism. Okay, in practical life also, the happening of any event is associated with certain chance. For example, there is a cyclone generating in the Bay of Bengal called Jawad. Okay, so how much will be the devastating power? Where it will fall? What will be the speed? So we are trying to make certain inference about the pictures that we are getting from satellite. We are trying to draw some inference or conclusion about these parameters, that what may be the landfall, the location of the landfall, the time of the landfall, the speed of this cyclone. Until and unless it happens, I cannot say it accurately beforehand. After it happens, it is easy to measure these values. Okay, but as you know that this weather forecasting, this is again based upon the inferential statistics. The entire subjects of weather forecasting is based upon the inferential statistics. That means we are taking pictures from satellite, the pictures that we are getting in the space, and we analyze, we apply certain laws, statistical laws. So image means nothing but a set of data. Huge set of data. Image is nothing but a set of data. Okay. Certain pixels, and pixels are nothing but sites, the data. So we are getting a huge set of data. And from this huge set of data, we are choosing a subset of the entire set of data. You understand? If I get a huge set of data, then it is not possible to study the entire set of data because that is not feasible practically. But your radar is giving you the continuous pictures of this Jawad, probable Jawad storm, cyclone for last 2 to 3 days. So you imagine how much data it is giving because continuously 24 hours it is monitoring and giving the data. But for us, it is not possible to analyze the entire set of data. So what we do is actually we pick a certain portion of the data. And the large or the bigger set of data is called the population. In statistics, we call that to be population. Population means the entirety. And from this population, we pick a certain portion of data. And this smaller subset we call to be sample. And from this sample, we then analyze, we make certain study and try to predict or forecast. Forecast what? The possible place of landfall or the position of landfall, exact position of landfall, the time of landfall, the speed when it falls in the land, so on and so forth. So these are certain inferences that we want to draw from this Jawad sample. What now people are doing? Now each of these parameters has a certain chance factor. That means you cannot say deterministically that this storm or this cyclone will fall in the Paradip Island at that time. Okay, only you can give a probabilistic measure, probabilistic prediction that it has the chance of falling. So any event which involves a chance mechanisms that is described by a probability. Okay? And the set of statistical rules, the set of statistical calculations which are being used to draw inferences from a sample of population that constitutes a branch of statistics called as the inferential statistics. Okay? So that is the idea of inferential statistics. And as you understand, the theory of probability forms the basis of inferential probability, inferential statistics. Now, in our theory, there are certain standard probability distributions. The mathematicians, they have formulated certain theoretical distributions of the probability of data. Certain standard distributions are there. Okay? For example, uniform distribution, binomial distribution, normal distribution, gamma distributions, so on and so forth. So, the mathematicians, they have already formulated certain standard probability distributions. It can be continuous probability distributions it can be discrete probability distributions. And then our task of inferential statistics is to study those distributions, and then I try to formulate my problem of weather forecasting in terms of those standard distributions. Okay, for example, if I consider the data of rainfall during the last 3 days, or from 3rd December to 5th or 6th December, if I take the volume or the amount of rainfall over a certain period of time at a particular location, then these are data. And the probabilities of those data, if I plot or draw, I may see that it follows certain standard distributions. So the very important task of inferential statistics is therefore to fit our experimental data with those standard mathematical functions. And if I be able to fit well my data with that standard mathematical functions, then for the well-characterized parameters like mean, mode, standard deviation, kurtosis, skewness, etc., of those standard mathematical functions will also be applicable for my data set. I know the descriptive measures of the standard mathematical functions, and if I be able to fit my data set with those standard distributions, then the descriptive measures of my data set can easily be calculated. So that's the beauty, that's the utility of studying those standard mathematical distributions. So it's very important for us to know the standard mathematical distributions, which we call as theoretical probability distributions. And there are two types of theoretical probability distributions depending on the random variable, whether it is discrete or continuous. So in this particular chapter, we will study both discrete probability distributions as well as continuous probability distributions. And there are many number of standard mathematical divisions, but we will not go for it. This will include uniform distributions, it will discuss binomial distributions, Poisson distributions, and some continuous distributions like rectangular distributions, normal distribution, and will solve certain examples, real-life examples corresponding to each of these mentioned theoretical distributions. So that will be the subject matter of this particular chapter. Is it clear to you? What is the objective of this particular chapter?
Yes, sir.
তোমাদের যদি কথা কোনো বুঝতে অসুবিধা হয়, please feel free to interrupt me and get it clarified. Okay. topics are summarized. I will mainly follow this particular book, which I have explicitly mentioned, that Statistics for Business Decisions by Dr. J. Kedar. Okay. So some of the pages I have scanned it and given you in the classroom, but many of the pages you will find that the picture quality is good, and you may find it difficult to read all the lines. So it is advisable that you get a copy of this particular book. It is very low cost book, within few hundred rupees, 300 or something, it's very low cost book. So you can easily purchase, and it will find that in your research career, in your academic career, this particular book will give you a lot of advantage, and you will many times you will follow this book for if you go for higher studies or research or any other jobs. In job market, a very, very, very lucrative area of job is now data science. And the entire data science, one of the pillars of this data science is this inferential statistics. So data science is nothing but the descriptive statistics and inferential statistics. Okay? So a lot of employment opportunities you will get if you understand what I will teach in this class and the prerequisites that I mentioned. At the same time, apart from this theoretical knowledge, you also need to be well practiced with any standard software. For example, but we will not do those things in our classroom, but I advise and encourage you all to learn two software. One software is SPSS. SPSS. It's a software from IBM, but you may not get it. The original version is quite costly. But there is a language for R. R for Rabbit. There is one programming language called R. And this R language, programming language, is very, very useful to do programs of statistics, both descriptive as well as inferential statistics. So, you must be, some of you, if not all, should learn this language R as a separate assignment. It will give you dividend in your future career. I'm saying this, that if you learn this language R, it will give you dividend in your future career, be it a research career or in job market. This is the one language, and another is Python, which I believe everybody will know. Python can also be used to write these programs, but R has more additional flexibilities because R is targeted for statistical application. So R is free, you can download it, the compiler you can download from the internet, you can install the editor RStudio and write your R programs. The manuals, they are available in net. Okay. So the first discrete probability distributions is the uniform distributions. Now, if I consider a random variable x, which maps. Okay, so the random variable x takes certain values, and these values taken by the random variable capital X, we denote by small x1, x2, x3, xn. So the random variable capital X can take a number of different values, x1, x2, up to xn. And if this random variable take those values with equal probability, if the probability of these real numbers are equal, then the corresponding probability mass function of this random variable x is defined as P of x is equal to 1 by n. বুঝতে পারছো? কি হলো? যেমন ধরো, is there any non-Bengali student among you who don't understand Bengali? তোমাদের মধ্যে এমন কোন স্টুডেন্ট আছে যারা বাংলা একদমই বোঝে না?
একজন তামিলনাড়ু থেকে ছিল, এখন সে জয়েন করেছে কিনা বলতে পারবো না।
কি নাম?
নাম তো ভুলে গেছি। আর মুশারফ বলেও একজন ছিল, বাংলা বোঝে বাট পড়তে পারে না, তো ঠিক আছে ওটা বললে অসুবিধে নেই। ও বোধহয় জয়েন করেনি, আপনি এখন বাংলায় বলতে পারেন।
মুশারফ আজম?
হ্যাঁ হ্যাঁ, ও বাংলা বোঝে বাট মানে পড়তে পারে না।
ব্যাস, ধরো ছক্কা আমি টান দিচ্ছি, সবাই টান দিয়েছে, ঠিক আছে। এইবারে কি হচ্ছে, কতগুলো পয়েন্ট হতে পারে ছক্কার উপরে? 1 2 3 4 5 6 এতগুলো ডটস থাকতে পারে। And this is a random experiment, the throwing of dice. You don't know what you will get at the top face. কখনো 1 পড়তে পারে, 2 পড়তে পারে, 3 পড়তে পারে, 4 পড়তে পারে, 5 পড়তে পারে, 6 পড়লে খুব আনন্দ হয় আমাদের, কখনো পুট পড়লে খুব আনন্দ হয়, ঠিক আছে। So there is a chance, everybody knows. তাহলে এই যে আবার যদি একটা কয়েন টস করছি, হেড টেল, ওকে, এবারে এইগুলো হচ্ছে সব স্যাম্পল পয়েন্ট। তাহলে র্যান্ডম এক্সপেরিমেন্টটা কি? র্যান্ডম এক্সপেরিমেন্ট ইজ দ্য থ্রোয়িং অফ দ্য ডাইস। And what are the sample points? In tossing a coin, there are 2 sample points, H and T, head or tail. And in throwing a dice, there are 6 sample points. 1, 2, 3, 4, 5, 6. Those dots, those number of dots are the sample points. Now, if I define a variable which maps each of this random variable, তাহলে যদি হেড টেলের এক্সপেরিমেন্টটা ধরি, let us suppose H or head is mapped to 1 and tail is mapped to 0. Head is mapped to 1 and tail is mapped to 0. Then this particular random variable takes 2 values, 0 and 1. Now, in the throwing of this dice, let us define a random variable which takes the value 1 when a single dot appears at the top face. It takes the value 2 when 2 dots appear at the top face. It takes the value 3 when 3 dots appears on the top surface. And ultimately it takes the value 6 when 6 dots appear on the top face. So the values that can be taken by this random variable lies from 1 to 6. So 1, 2, 3, 4, 5, 6. These are the real numbers taken by a random variable. So this we sense, it is actually a function, a mapping function. Now, the probability of taking the values 0 or 1 is equal in the case of throwing a coin. And the probability of 0 is 1 by 2. The probability of 1 is also 1 by 2. So these types of distribution is a very simple example of discrete uniform distribution. Similarly, the probability of getting 1, real number 1, is 1 by 6. And it is same as the probability of getting 2. It is same as the probability of getting 3, number 3, real number 3. Same as getting real number 4. So you see that if there are n number of real numbers, so if there are n number of real numbers, then the probability of each of these numbers is 1 by n. And the probability mass function of x is px is equal to 1 by n. So x is therefore follows a discrete uniform distribution. বুঝতে পারছো? Discrete uniform distribution. Now, once I come to know probability distribution, we can compute certain statistical parameters. The first important parameter is the expectation parameter or the mean. You are familiar from your undergraduate courses that the expectation of x, of a random variable x, Ex, is measured as summation x into px. And the summation lies from 1 to n. If there are n number of data points, if n number of numbers that can be taken by the random variable capital X, then the expectation of this random variable E of x is equal to summation x into px, where the summation extends from 1 to small n. Okay? So if you compute this expectation for a discrete uniform distribution, you will find it comes out to be n plus 1 by 2. It's very simple. These calculations are given in the book itself. And you can also derive those things. I strongly suggest that you derive the mathematical expressions. Only then you will be able to understand. So E of x is equal to n plus 1 by 2. Now, the another important descriptive measure is the variance. Variance, you know, variance is the mean square average. Okay. We calculate the deviation of each data point from its mean. The deviation can be, deviation means x minus x bar. If x bar is the mean of all data points x1, x2, x3, xn. If x bar is the mean, then x minus x bar is the deviation. Now this deviation can be either positive or it can be negative. If each individual point is lesser than the mean, then it's negative. If it's greater, then it's a positive. So in order to avoid the sign in the plus or minus, I take the square. That means x minus x bar whole square. And then I take the mean over the entire data set. That means 1 by n summation x minus x bar whole square. That gives you the variance. And the square root or the root of this variance will give you the standard deviation. Now it's a very simple formula that for a random variable capital X, the variance V of X is written as V of X is equal to E. E means expectation operator. তোমরা কি বুঝতে পারছো তো? এটা যদি বুঝতে না পারো তাহলে মানে একটু আমাকে বলো। পান এটা আমাদেরকে ধরে নিতেই হবে। হ্যাঁ, E operator means expectation operator. So E operated on x square minus EX whole square. E square x means E of x এর whole square. তার মানে মিনের স্কোয়ার। এই ফর্মুলাটা একদম একটা সহজ ডেরিভেশন করে আসে। Then how you calculate the E of এবার E of x square, E operator is operating on x square. It means summation x is equal to 1 to n x square px. Okay. এটা আবার কোথায় গেল? পাতাটা মিসিং, লেখা পড়ে না কেন? আই বাবা, এটাই করতে হবে, আর কি করা। করে থাকি এই ডেরিভেশন গুলো তুমি করবে। এটা হবে n, এত বড় n plus 1 into 2n plus 1 by 6. Okay? এটা হবে e of expectation of x square. তাহলে ভেরিয়েন্সটা কত হবে? অলরেডি আমরা এখান থেকে জানি কি মাইনাস n প্লাস 1/2 স্কোয়ার। তাহলে ভেরিয়েন্স ফাইনালি তুমি পাবে ক্যালকুলেশন করলে v of এটা আবার কি হলো রে? সেভ হয়ে গেল। তাহলে v of x আচ্ছা যাক, এর উল্টো পাল্টা হচ্ছে, পরের দিন এটাকে ঠিক করে v of x is very simple, n square minus 1/12. v of x is equal to n square minus 1/12. ওকে, এটা আমরা করলাম। টুডে আই সি দ্য টু ইম্পর্টেন্ট একটা ইম্পর্টেন্ট ডিস্ট্রিবিউশনস আমরা আলোচনা করলাম, ইউনিফর্ম ডিস্ট্রিবিউশনস। ঠিক আছে, আজকে আমরা এখানেই শেষ করছি। পাতাগুলো পরে আমি ইনসার্ট করে নেব। এবার যদি কারো কোনো বুঝতে অসুবিধা হয় তাহলে জিজ্ঞেস করতে পারো, কিন্তু বইটাকে সাথে তোমরা রাখবে। ইটস অ্যাডভাইজেবল, আদারওয়াইজ ইটস ভেরি ডিফিকাল্ট টু টেক দিস ম্যাথামেটিক্স কোর্স অনলাইন। আর যদি কারো কোনো বুঝতে অসুবিধা হয় তাহলে সোম, মঙ্গল, বুধ আমার কলেজে চলে আসবে, আমি রেগুলার থাকি। ঠিক আছে, কারো কোনো প্রশ্ন থাকলে করতে পারো।